Okay, so I've spent the entire day reading and it's taken a lot out of me, but I'm finally done so we can do the daily dev video and try to at least keep up with the pace we're trying to get with. Now, yesterday I did do a video. It was really short, didn't really get to much. Today we're not going to end up doing what I said we were going to do yesterday, which is work on a few of the blocks and stuff. I still don't quite have the time to do that, but I am going to talk about a few different ideals that I generated yesterday. So when I was at the party for my cousin's graduation, I didn't really do much, of course. I mean, I go to those parties more to of the requirement to be there and not much to socialize, as I'm pretty introverted when it comes to talking to most of my family. I'm more open to talk to you guys, users, and even my buddies online than I am to talk to my own family about things. Especially when I got into a conversation with my grandmother about robotics, and she told me that a robot can't pick a strawberry, and when I know for exactly sure that they do have robots that can do exactly that. I even considered sending her a couple of videos, but then I realized that she doesn't have anything over dial-up at her house, so that wouldn't have gone over well. Anyways, so we're going to more than likely spend a little bit of time looking at the heated stone again today. I did change its colors. Let me go ahead and up this. The color scheme I picked is not much of an improvement. I still have to spend some time on this. We do have full 16 complete colors now, although a couple of them are repeats of each other. I got the colors from Wikipedia here. After I did some Googling, I found something that did show a color scale amount. The colors do not apply very well to Minecraft though, so I'm gonna have to experiment. More than likely what I'll do is I'll create an array and I'll catch the colors. But what I did really quickly is I grabbed this table right here, which I did. If you view page source, you can actually get the or not the RGB, the hex colors out of here, which are right here. So I've grabbed these, and these are what you're seeing down over here. So I made sure to link that source there, so if anybody finds the code, they know where I got those colors from. But these are going to be changed. They look okay. When you get to the higher range up here, you get a nice orange color. When you start to get down to the lower color, it starts to turn kind of a light brown before it turns back to the regular color. The light brown really does need to be fixed, and I'm going to have to spend a lot more time on here. One of the ideals I did figure out yesterday, and I did actually spend some time writing notes on it. I figured out how much data it's going to use on the game and everything, is to actually create a table of metadata values that are stored outside of the normal game world. So right now we're limited to 16 values for metadata, which limits our ability for color ranges. But if I create another version of metadata that saves and loads, I can now take this to whatever number I want to be. Let me find my notes really quick here. So yeah, I got a lot of notes from yesterday here. I was working on radiation math too while I was sitting at that party. Got some little odd questions from my uncle that was going like, why the hell are you doing that? Although he's surprisingly a little bit more understanding than some of my other relatives about this kind of stuff. My other relatives were like, they give you that stink eye and go, you shouldn't be doing that at all. But they're the kind, because one thing I've never mentioned on videos is most of my family are tradesmen, so they do things like work on cars, machine things. Very few of our family ever go into science fields. I'm probably one of the second or third to actually do it, with my aunt who's actually a chemistry teacher, and then now I'm becoming a scientist here. So anyways, ignoring my notes on radiation here. So the ideal is that when I originally started doing this math, I was looking at how much data it was going to take to work on our radiation map. The radiation map, which I've already started on, if I can scroll down here and ignore my dog, which is whining in the background. Let's see. Oh, if I can find it down in here. I completely lost track of where everything is. Actually, you know what? Give me a second to step away and walk my dog, and I'll be right back. Okay, through the magic of video editing, we are back here with no interruption in the amount of time. Unfortunately, my dog didn't actually want to go for a walk. She just wanted to whine at me, so I would throw a toy at her a couple times, and she could go chase it. Anyways, back to the notes here. So I worked on a lot of math and figured out how much data we're going to use for the radiation map. Now let me go ahead and find the radiation map here. So that should be world, and it should be map, radiation. Now I did show a little bit of this, but I didn't really explain a lot what's going on. Now the radiation map is not very complicated. It is incredibly simplistic, like anybody could use this for anything. More than likely what I'm going to do is I'm going to recode this to be generic. So instead of calling get radiation, it'll just call get value set value, and that value would be a short, which is 2 bytes from what I wrote down. Yet 16 bits, which means it's 2 bytes. So this would be really easy to use. I am actually tempted to use 2 byte maps instead of using a single short map to allow for more data, especially considering I'm still not exactly sure how we're going to store radiation just yet. The number one way I'm looking at it right now is going to be RIMS. So RIM is the risk of radiation poisoning to a player, and then RADS is how you store radiation on an entity. So it's really likely we're going to use that because that number isn't very big. It goes, I think the maximum it goes up to is about 20,000, and a short is 32,000 in size, so that'd be perfect. The one risk is, though, we want to be able to simulate really high radiations for things like Jupiter. Jupiter has an incredibly high radiation amount around it, so even if you're in a spaceship that's a couple 100 kilometers away from Jupiter, you could suffer from severe radiation poisoning. Anyways, going back to this, so we got a radiation chunk. This stores sections. Of course, this isn't finished. I started on it and then I got it planned out. Then the data manager is where you're actually going to access the map. It's completely empty. We haven't done anything yet in here. But if you actually look at this, this actually already uses a prefab called chunk section short. This is very similar to how the chunks work in Minecraft. The Minecraft chunks use extended data storage or something like that, which then stores an array just like this. This gives us 4,096 blocks per layer, and there's 16 layers, which means we end up with that, surprisingly, that number of blocks addition to that this uses that amount of memory. When this taken into account, if you look at a 16 by 16 chunk area, this only adds 34 megabytes to the map. So this is really low on the memory size. The only problem this comes into play is if we're talking about heat maps, it's going to use a lot more. But for our extended chunk data, what I'm thinking about using is either another short map, which would add another 34 megabytes per 16 by 16 area, or if I use a byte map, it would use 20.5 megabytes because you're basically cutting it in half. And then I calculated out to what it would be for, let's see if I can find the numbers here. I should have had one in here. Yeah, here it is. So for a 12 radius, which I think is the maximum size you can actually chunk view as a player, I don't know if the range goes up above that, but it's 41 megabytes for a 25 by 25 chunk area, which is not bad when you consider the fact that you usually roughly run Minecraft with about 2 gigabytes. So 41 megabytes additional is going to be nothing. Reika's machines in his mod do more than that on average because he is not good when it comes to computer science. Hopefully he learns eventually that there are certain things you're supposed to do and certain things you're not supposed to do, because I mean he's got good mods. I mean, if you guys ever seen Chromaticraft, it's probably one of the best magic mods I've ever seen. Anyways, ignoring all that, so what that applies to is when we go to the heated block here, I can decide to take this out to 32,000 different values. Now, I do already have a plan of how to handle this. We are going to use the heated map for the heated stone. So what's going to happen is there will be a heated stone placed. And then we're going to use the extended block metadata to log what block we are. So if we're heating up stone, we're going to be ID 0. If we're heating up cobblestone, we'll be ID 1, and so on and so on. This way we can support an infinite number of blocks. Well, not infinite number. We'll be able to support 32,000 different blocks. Then we're going to use the metadata to simulate extended states. Then we're going to use the heated map to actually extend the temperature. So what we'll have is we'll have a float-based temperature value between 0 and 1, and then we'll have some kind of color scale that will come back through here. And we'll raise and lower the color scale to reflect just how hot that material is. And of course, we'll have state changes and stuff, so you'll have the material be able to go from a frozen to a solid, or go from a solid to a liquid to a gas state. Gas states are not going to render via the normal Minecraft system. We're actually going to do this via an external system because we'll be using fluids for that. I don't want to make a block per fluid. This is the same thing when we go to do our molten materials. We've already kind of experimented with this already actually almost a year ago now. I looked at the possibility and I realized I was going to need 1 block ID per metal, and we were looking at the possibility of having 50 different metals, not including alloys. As soon as you throw alloys in there, you just blow all possibility of what you can and can't do. So you're talking 50 block IDs, and then you multiply that by maybe 10 times. You end up with 500 to 1,000 different block IDs, and the game has a limit of 4,096 block IDs with Forge, and you can't go past that at a certain point. Now, Okay, sorry, I got interrupted there for a bit. I'd locked my dog out of my room and my mom wanted to know why. So where were we at? I completely lost my train of thought. Um, so yeah, there's a lot of stuff we want to do with this, and there's a lot of different things we're going to do. We can't do a block ID per liquid. We definitely can't do one per gas because there's so many different gases. And then on top of that, if we even do a block ID per gas, it prevents us from doing really cool things like mixing the gases together. This is the same thing for liquid. One of the things I want to really do, and I've wanted to do this for like about 4 years now, is being able to mix liquids together and you as the player being able to watch that happen. If you guys have ever dropped colored dyes into water, you can watch the colored dye go through the water. It's not dilution. There actually is a name for it. I used to know the terminology because I used to study it for a while, but it's really, really cool to watch, and I want to be able to do that in Minecraft because it won't actually be too CPU intensive to do, especially if you multi-thread it. You'll notice no impact on the game itself, but it'll allow a really complicated way of gameplay. Especially if I implement fluid mixers. I do have some drawings of this I made several years ago for a mod gem where we were gonna do a fluid mixing mod so you can make potions in bulk and then make all kinds of things. Like we were gonna put soda in the game just so you can make a soda factory. But anyways, going back onto this, let's go ahead and I guess start working on making an extra metadata map. So we're just gonna call this. Shoot, we don't have a name for this. I don't want to call it data because we already have a data package in here. We're going to call it block. Because what we're doing is we're extending the block. And one of the big things with doing this is this can extend not just our ability to do what I was talking about of just adding different metadata values for different textures, but we can go beyond that. So I can say, okay, you have an energy-based pedestal that can charge up a set item. Instead of making a tile entity for this, I can make a block and then we can iterate through our phases using the block's metadata exclusively, and then you don't have a tile logic is updating. You don't have to do anything else, it just runs. It's really, really useful. This, at least is what in theory it's going to be useful. What we're going to do is, yeah, I'm going to change this. So this is going to be chunk data short. And we're going to go toss this into the data folder. That way I can recycle it. And what we'll do is we'll make a sub package real quick. We'll call it short. Because what we'll do is we'll make versions of this that'll be integer and stuff. We may do double versions of it. And why did it not copy the other one? I highlighted selected both of those and it only copied the first one. That was... Oh wow, it failed to do the package too. Oh, what the flip is going on with this? Oh, we named the package the same as... Okay. I didn't want to do that. You know, this is where IntelliJ should have a feature in here that would have blocked me from doing that in the first place. Because it's basically broken. You can't do anything about it here. At least I don't know why IntelliJ also has that thing where it's like, hey, we're gonna do this and we're gonna do that, where we're gonna want to rename all of your comments as well. It's something that really shouldn't have happened, and it killed all my imports in here too. Man, it like completely screwed up a lot of this in a very short period of time. Anyways, ignoring all that because I don't want to sound like I'm just frustrated about IntelliJ being a really poor piece of software, because the reality of it is it's actually pretty good. It's got a high learning curve, I do admit this, but so far it's been one of the better Java IDs I've worked with them. Okay, so there's not a lot we gotta really do with this. What we gotta do is go and get the section. So s equals, I think it's gonna be, I think it's just y%16 to be honest. No, that's not it. Divide by 16. That might work, because if if you're going from the bottom up, so you're between value 0 and 15, you divide that by 16, you're going to end up with 0. So that will work. And then what we want to do is we want to go, okay, if sections.s doesn't equal null, then you just return sections.get, or yeah, sections.s.get value, and you're going to be x, y, and 16, because I think and 16 actually does a bit shift version of what we just looked at, and it works out pretty well. And that should do the trick. Now the else statement we want to do is we want to go, okay, sections.s equals new chunk short section. You don't really need to do anything with it. You just then need to basically call the same thing on it. Yeah, actually, no, there's a way we can simplify this real quick. And we can go, okay, if equals null, then you just initialize it really quick. And that will cut that code down a little bit. Now set value is pretty much the same process here. So you would just want to copy this down here, and then you want to, we actually want to return what the previous value was. So you're going to want to do this, except you're going to want to store it. So you're going to go short equals, actually there's an even better way we can actually do this. Nah, we'll just do it, we'll do it the better way. Or we'll do it the way we're currently doing it. Not a lot of reason to go out of our way right now because we haven't really tested this, and we're gonna do a lot of the testing today through JUnit because I'm not gonna implement this in the game right now, but we can get started, and then hopefully here this next week we can then start implementing it, and we can play around with the radiation maps and play around with our extra data because it would be really cool to do all that stuff, and then hopefully here next couple weeks I'll get done with the 1.8 update and we'll be ready to start seeing if any of this stuff will port to the newer versions. It's one of the reasons why I haven't implemented a lot of this code until now is that I'm still not at all sure if it'll work in 1.8. If I find out it's not going to work in 1.8, there's a high possibility I may just stay in 1.7 with a lot of these features, and the newer versions just won't have them, which would ruin my whole plan of producing ICBM over multiple versions with a lot of cool content, but you can't be picky sometimes. Anyways, when it comes to this, we just go like this, and we go set value, then we just grab the same data here, and then we put value in there. Let me take a look at this. Yeah, that doesn't return the previous value either, but we don't need to worry about that. We're going to do the previous value here. So this will work. So this will give us our get value, so give our set value. Then we need to go take a look at our radiation map and see how it's handled. Oh wow, you can. All the imports are probably going to be broken over all this stuff because of the fact that IntelliJ goofed and did not do a backup before it did anything. So like if I was working as a database manager, by the way, and I did exactly that, I would have got fired. IntelliJ gets away with it because, well, IntelliJ. So the thing is, we can just rename this whole thing, but I don't know if I actually care enough to do it. Yeah, I'll leave it how it is. Because what we're going to just simply do real quick is I'm just going to copy these two, and we're going to take it up to the block. And this is, of course, going to be our extended block data. Extended block data manager. This will be our extended block data map. And what you do in here is you change this exactly like I was saying earlier. Just get value, set value. And then you just change this to extended block data map. And then you're good. Not a lot you got to really do with these. We just got to work on the data manager so you can retrieve the maps. What we're going to do for this is we're going to take a look at the radar map, or radar registry rather. Now radar registry is a chunk map. It just doesn't function the way the rest of them do. It's the reason why we didn't use it as a prefab, is because if you go look at the radar map, it stores a list of radar objects at each location. Now what I could have done is I could have created an object for this, but I'm just using a list because it's so by far easier. and then it stores a list of all entities, and it works that way. You just go, okay, I want to know what entities are in the chunk, and then it grabs the entities in the chunk. The reason for doing this is if this list contained like a million entries, you wouldn't want to iterate the whole list. It just would take too long. But if you wanted to know everything that was in like 10 chunks of you, it's real easy to do with this because you're only going to have 100 chunks to iterate through instead of iterating through a lot of this. And maybe each chunk only contains like 10 guys, so you've only iterated 1,000 entities versus 1 million entities out of that list. So it's a really, really useful system. We're not going to look at the rest of the radar map because there's no point. But we are going to take a look at the radar registry a little bit. And there's not a lot we really got to do with it. We need a world to map cache. Now I might prefab a little bit of this. So let's go to data. And what we're going to do is create a class called chunk map manager. And then we're going to want to grab this guy. Now we don't want him to be static. We do want to keep it final though. And we're going to change it to protected so that way we can toy around with it from inside of our sub-objects. This is going to be a list of worlds. And there's a few things we're probably going to grab out of this. Chunk unload, world update tick, and world unload. Actually, the chunk unload we don't even need to worry about because that's actually handled by each world now. I transitioned that code over. World update tick. Okay, so yeah, we need a bit of work here. We're going to do that real quick. We're going to transition this to M. Let's change this. So we're going to change this to world map. And then we're going to really quickly rename these guys. So we do need to make sure we get our world here. So it's going to be C map equals world maps.get dem. The reason why I use the character C here, which is not working, oh, this M is what we're actually using. That's the reason why it's not working. We want to go map.unload basically. Yeah, just put an event down here. Public void on world unload. Use for cleanup. So what will happen if you unload the world and you had data stored here? You'd basically save things. So go to do save data. So right before you unload, you save everything to the map, and then you clean up any junk you got sitting around. So say if you had, like we were doing in the radar map, we were storing a list of entities, you would want to clear that list of entities out. You wouldn't just want to leave it there because it won't unload properly. So this will be map.on, or just world, yeah. What do we call that? Like I must have not been mentally paying attention at all. Yeah, right there it is. Oh, weird. That's apparently not a method. Oh, because we typed in the wrong thing up here. Okay, so there's world unload. Apparently map does have an update method in it. No, it doesn't. Oh, because we wrong map here. We do want to get a map per dimension thing. However, we can just do that real quick. Is valid. Do that real quick. Create getter. Return true at the moment because there's nothing really to do. Actually, we can do this real quick. Go should unload. Yeah, if you don't have any chunks, you might as well unload. That's a good way to do that, and then we'll create an update method. So create method. And this we're going to put a little further up the tree because it needs to be. What we're pretty much going to do here is to do check if chunks are still loaded. So this is going to be your backup if, say, for example, your chunks unloaded by mistake or something. We're going to need a tick system here. I wonder if there's a way to pull ticks from the world. I'm pretty sure there is, but it's been a while. Let's see what tick does. Updates weather. Yeah, I know there's basically a world clock, not the day world, but there's one that actually tracks how long the world has been loaded. Maybe it's provider. There's a get world time, but I don't think it's what we want. We're not going to worry about it, and what we'll do is we'll just make each map keep track of its own tick time because it'll work. So what we'll do is we'll go protected, or protected long ticks equals 0L. And we'll just go if ticks percent like 200, which is every 10 seconds. Then we'll just say, okay, we want to do that or this or that, whatever. Called each world tick to update. Document that real quick. So that gives us some of our main functionality here. We're going to do a method here. So we're going to public chunk map manager. And then in here, we're going to go if engine.is JUnit testing. We want to make sure we're not registering events if we're JUnit testing because they just flat out won't work properly. You want to test any of your event fires manually. Just always assume that Forge is functioning properly, so you don't need to actually test that Forge is doing its own thing. That's something that Forge would have to test, not us. So you want to register this, and let me make sure that these are, okay, this is an FML event. And this is a Forge event. So the world tick is an FML, so I'm going to have to do Forge, no, it's FML common handler instance bus.register this. So you have to register this to get this one, and you're going to have to register this to get this event fire. Then what we also want to do in here, since we're working on a manager, we want to go public m get map for dim and dim, and this one's going to be pretty straightforward. Well, you know, we're going to do an extra thing here, Boolean create. So we want to go if worldmaps.contains dim, then you literally just want to return worldmaps.get dim. Return null by default. Then you want to go okay else if create. And you want worldmaps.put dim and then new map, I guess. What we're going to do here is go, have to make this abstract because we're going to have to make a method for creating. Create new map and dim. And this, of course, has to be abstract because we don't know what that map object's going to be. So we don't know what the class of that is, even though it could be an instance of chunk map. It could be a short map, an int map, or something. We're not sure what it is at the moment. So you're going to create map, pass dim in there, and then you want to return this because you just stuck it in there, so it should work. It'll get us our for that, and then just to make life a little easier for anybody who wants to use this system, we can go okay get map world, and this would return get map for dim using world dot provider or whatever. Make sure I import that. Provider.dimid. And then of course we want to do Boolean create Most of the time, this is going to be set to true because you kind of want to create things by default if you're calling them. The only reason we're going to use it is because there's going to be things like, okay, do we want to check if a map is loaded or not? So, for example, when we're doing our update tick here, we can call get world for dim, and then we could do false. And we can do that for down here as well. That way we're recycling and using those methods, but then we're saying, okay, we don't care if the map is there. So if it's not loaded, don't load it, or anything like that. Additionally, to do load instead of creating. So one of the things that we additionally need to work on with a system like this is we need to go, okay, this world was unloaded, but we had a map for it. So we might want to go check the hard drive and go, hey, do you have a map saved for this? How do we do that? So we go or I think we can do it this way. We can do a loader create check. Protected m load or create and dim. And then we'll put this here. What we'll do is, okay, we'll return this by default. Actually, we'll do void here. We're not going to do a return on this. We're going to do load or create and then provide the dim here. And then we want to create some kind of save path. So we're going to do our save path up here. Save folder. And then we'll store that. So we'll go public final string save folder. It'll be like this dot save folder equals save folder. By default, everything is going to be forced to be saved inside of the BBM folder inside your world directory. So how do we want to do this precisely? This actually means we want to also do this. Implements I virtual object. This is a system I've created to more or less keep track of things like this, where you have an object that really needs to be saved every single time the world saves, and it will handle all the saving and loading for you. Sort of, you still have to do the loading on your own. I might eventually get around to doing that, but it's a little tricky, especially when we consider the fact that I kind of want to transition the whole system over to using a database. Oh, come on, Taz. This dog is, I don't know what. She's been fed, she's been watered, I've walked her, yet she constantly wants attention. Come on, can you wait till I'm done recording? Oh, no. What? Okay, we're going to try to do this with a dog on my lap right now. Okay, so we want to return our save file. So our save file is going to be a set file here. We're going to want to catch this. So be protected file save file folder. You know what? Actually, let's not make this the virtual object. Let's make each of the maps a virtual object. Let's see. So we'll keep that where it's at, and so I just realized what this is going to do is it's going to set a safe. We'll do another interruption here real quick while I take care of my dog. Okay, so we'll return here. I forgot to cut the recording here, so there's going to be an interruption point there. I do apologize. So the only thing the dog actually wanted, by the way, was for me to cover her up. I swear my dog is a little kid. Anyway, so yeah, we aren't gonna make the map manager the save object. We're gonna make the chunk maps the save objects. So we'll implement iVirtual object on here, and then we'll come through and we'll implement this on here. Because that means each object will have its own save name, and we'll actually keep track of its stuff itself. Now the save names, actually I'm going to leave the save name null here because, actually, you know what, I have to supply these. I don't have to do anything with these two methods down here though, to be honest. So this one could be empty because it doesn't get used really. This one's going to have to keep track of a few things here. So what we're going to want to do is we're going to do chunk map manager, and we're going to store this in here, that way we can access its save location. This map manager equals map manager. This way we can also get track of a lot of extra data. Like if we, for example, we made a version of this that allowed you to teleport between dimensions, it would be useful to be able to track this information. So we'll do that. And then this one's going to be, if it's going to cooperate with me. Okay, so return if dimid equals world.provider.dimid. Why is that? Oh, we're missing an equal. Add override, and then here we're going to return new file. And then what we want is mbt utility.bbm folder plus mod manager, or map manager, save folder. And let me check to make sure this has a, yeah, it has an end on there. So this will be save folder location, and then it's literally going to be dimid plus dat. It's not very complicated. Actually, what we want to do is we're going to put in some kind of name in front of this. We'll do it this way. So we'll go protected abstract string save name, and then they just have to implement that. And it'll be save name plus underscore dimension ID. So this is an example. If we're doing a radiation map, this will be radiation map underscore dimension 0. That way it's real easy to track that. And then on top of this, what we want to do is go mbt utility.get save directory. That way your front path is going to be, for example, say you had Minecraft installed on your desktop. It would be your username desktop, then it would be Minecraft saves, the current save you're in, for example, World 1, and then it would be BBM, whatever the save folder is called, your save name is that where it would be stored at. This makes it real easy, and then when we go to do this stuff, we then want to go, okay, save manager.register this. What this will do is it will automatically, every single time a world calls a save call, it will save this chunk data for us automatically. So it'll essentially, ironically, save us a lot of time. Not ironically, but ironic when you think of the word usage. Now, when it comes to the load thing, this is where it gets a little tricky because we're going to need to know what our save name is. Actually what we'll do is we'll go public final string file save name, and we need to differentiate too. So this would be the name of the folder, and this would be prefix name of saved files. This would be this dot save file name, or file save name equals save file name. That way that's stored, and then what I can do is I can come back to the chunk map we were working on, And I can get rid of that method down here. And we can just go, okay, map mod manager dot file save name. So that'll make it consistent, and that way we don't have to store the name of the file in two separate locations. It's stored only once. And then we can do recreate the file path, which this is where it gets dumb actually. What I'm going to do is I'm going to copy this, and we're going to come up to here, and we're going to put a method here. Get save file int dim. And this way we could do this on here, so we aren't making two separate methods. This is where when you want to make your code reusable as possible. And then you come down here and it's just mod manager, or I mean map manager. I'm going to get the two confused back and forth. Try to keep up. Apologies for my brain not functioning well enough to not get the two confused with each other. So we want to go if file equals get save file dim. If file dot exists, you want to make sure the file exists. If there's no file there, there's no point in trying to load it. Then you want to go mbt tag compound tag equals mbt. Yeah. mbt tag no, mbt utility dot load data from file. Yeah, we're just gonna put an else statement right here because this will work. Or no, actually we're gonna need. So we're gonna go m map equals create new map. We're still gonna need to do put the map in here. What we'll do is we'll call a load method on the map. So we'll go okay map dot load tag. Is that load even stored at iSave? I want to say I'm going to have to implement this stuff here. Now here's where things get kind of really tricky, is how do we want to save the maps? Do we want to save as one large file, or do we want to save as several small files? And how do we differentiate that? How do we control that? How do we manage that? I want to save as small as files as possible, but then that changes our behavioral system. Let's go ahead and make sure that these methods are implemented. We're going to keep track of a virtual object for the whole world as a whole in case you want to save global data, but then we're going to save everything as chunks as well. I'm not exactly sure how Minecraft does this. I'm pretty sure it's resource intensive because Minecraft has not exactly done the greatest job to ensure that game saves are fast. But I'm not to say I'm going to do much of a better job because, in all honesty, I haven't done a good job with that either. So we're going to save individual chunks, and we're going to do a few other things. So we're going to call load on here, and then what we're also going to do is call map.onload. I don't want an abstract method here. I actually want a normal method. Put this like this. Called after the map has been loaded from disk, should be used to load chunk data. And then we'll put thing down here. We'll go okay to do load chunk data. And my comment here not used. Actually, you know what I'm going to do real quick? I'm going to go up to here, and I'm going to make this a default, because it's just never used. You can tell it's never used because I haven't indented the spaces on here. And then that way I can come back here to the chunk map, go down and just remove that completely because then it's not required. It's a great thing about defaults. You can implement them in such a way that you don't need a whole bunch of special stuff. Okay, so we got load, we've got save. We're not going to do anything with these because there's nothing important to do. Like the stuff you would do with this is if you were storing global data in some particular way, like what direction is the wind currently blowing on as a global value. But you're going to want to do chunk data. So we're going to want to load a whole bunch of chunks, which means we're going to need a folder. Reminds me, when we go to save, we're going to want to do some save things. What we at video time? We're at 41 minutes. Might just call it a day here in a second on this, because we got a lot of work to do, and so we're going to call this is going to be radiation. Oh, you want a mod manager. Okay. So we're going to do this will be radiation data manager. And this will pass manager back in. This will extend chunk map manager. And this is going to be radiation map is what the object is going to be, and then we'll implement methods, create new object, and then we'll implement everything else here. And we'll get back to this later. But I'm going to go ahead and end this here, and I'll see you guys another time, and hopefully I'll get enough work on this that we won't have to spend too many videos just doing the boring stuff. But I'll try to do a couple videos showing how to do JUnit testing, because it is something you guys keep asking me, and my email is how do you JUnit test a mod, how do you do this and that. I might actually take a pause and do separate tutorials on that later, but we'll see how things go. I mean, nothing's planned so far, so yeah.